when a CFD simulation is running, it basically solves for 3 or 4 fundamental quantities. What are those quantities? Pressure, velocity, temperature. Obviously, if you have turbulence, you're going to solve for that also. But let us say pressure, velocity, and temperature are the 3 fundamental quantities. From pressure, from velocity, you can calculate your shear stress, and then you can calculate your drag forces. So from your pressure, you can basically integrate the pressure on top of the surface of your car and get your lift forces or down forces, depending upon what you're looking for. All right. So these are the outputs that you look at. So for example, if we go back to this CFD simulation, what am I doing? What am I doing here? I'm coloring this car by pressure. Now, what I'm looking for here is qualitatively, the results should make sense. Meaning, I know that these results are wrong because first of all, the wind tunnel is too small. And secondly, I did not throw a lot of computing power. I ran the simulation on a relatively smaller computer. So I know that the results are not super accurate, but from a qualitative point of view, what are some of the features that you see in the simulation that make sense to you? Guys, what are some of the features that you see in the simulation that makes sense to you? This is the most important part. Running the CFD simulation is, you can do it after you get trained, and basically interpreting what you're seeing, that is the most important skill set. So can anyone tell me what are some of the quantities that look correct in this particular picture, in this particular simulation? Nose cone, high pressure, exactly. More importantly, the thing that we are looking for is look at your wings, right? You have low pressure on the lower end and higher pressure on the top. So what does this mean? How can I calculate the downforce? Well, I have pressure. If I integrate the pressure on this area, I can get the force, right? And I can compute the downforce. Similarly, rear wing, right? In the rear wings, this is a multi-layered rear wing, as some of you know, right? And this is in the multi-layered rear wing. What is one of the important quantities that you look at? Does anyone understand? Does anyone know that? Okay, looks like many people are not aware of this. That's fine. So basically here the gap, right? The gap between 2 consecutive wings is very, very important. Now in this case, you can see that the gap between the second and third wing has actually been shut down. So this simulation is wrong, right? But this is actually, since it's a made up model, you can kind of showcase these defects. So whenever some students send out their simulation results to me for, consulting, but when I look at them, they make these type of mistakes. If you're making these mistakes, then that's going to give you completely bad results, right? So in this case, there is supposed to be a flow passage which has been blocked. Why has it been blocked? Well, during the process of surface cleanup, I think the student accidentally just closed this part. Because of that, there's no flow path there, which is bad, which means the solver thinks that this is an entire wing and there's just only 2 layers. In fact, there are actually 3 wings here. And you can kind of understand that just by looking at the cut plane. So if you look at the cut plane, right, you can see that between here, where is my drawing tool? So here you can see that there's a disconnect. Maybe I'll use a black color. Here you can see that there's a disconnect, but here you can see that things have been joined. In fact, this flow path is very crucial because it helps in doing something called as energizing the boundary layer, which is very important because that helps you in preventing flow separation, which is a very much desirable outcome whenever you do aerodynamic analysis, because that helps you in reducing drag forces.